So design of observation pond. The second is the detention period. So the removal of the BOD in the pond follow following equation. So this is the equation. LR is equal to LA in bracket 1 raised to 10 raised to minus PT into T, or T is equal to 1 divided by PT log of the 10 in bracket LA divided by LA minus LR bracket complete is equal to 1 divided by PT log of 10 LA divided by LE, where LA is equal to influent BOD, LR is equal to BOD removal say 90% of LA 95%, LE is equal to BOD remaining in the influent. PT is equal to BOD removal rate constant for the pond at temperature T degree Celsius. T is equal to detention time in days. The removal rate constant at 20 degrees, that is P20, is found to be approximately 0.1 days. This at any other temperature will be. So following the formula of the PT is equal to P raised to 20 in bracket 1 minus 0.47 T minus 20 bracket complete. So next is the depth. The optimum range of the depth for facultative pond is considered 1 to 1.5 meter. When the depth is determined from surface area and detention period works out lesser than 0.1 meter, the depth should be increased to 1 meter, keeping surface area unchanged. When the depth works out to be greater than 1.5 meter, the depth should be restricted to 1.5 meter and the surface area increased to give the required detention period. Then next, sludge accumulation. The rate of sludge accumulation in facultative pond depends preliminary on the suspended solid concentration in the influent waste. The reported rate of the sludge accumulation in the pond creating the municipal sewage range from 0.05 to 0.1 meter cube per capita per year. The value of 0.07 meter cube per capita per year forms a reasonable assumption in the design. The desludging at interval from 6 to 12 years. So next unit, number of units. So then multiple units are required to be provided when the area is exceed 0.5 hectare. These units can be either in series or parallel. Multiple system in parallel provides better distribution of settled solid. The multiple cell in series enable better coliform removal and reduce algae concentration in the influent. This series system implies a high BOD loading in the primary cell, and to avoid anaerobic condition, they should have 65 to 75 of total surface area requirements. A parallel series system consists advantages of both. More commonly, two units are kept parallel and serves as a primary pond, while third serves secondary pond in series. Then performance. The well-designed facultative pond gives about 80 to 90% of BOD removal based on filter of 5 days BOD influent. So next point is a design of observation pond. So this is the design parameter, design of observation pond for following data. So the data gives to location, then elevation, then mean monthly temperature, then population, then sewage flow, then desired influent BOD 5, then pond removal constant at 20 degrees Celsius is equal to 0.1 day. Then sky clearance is at 50%. The location is used 20 degree latitude, elevation 900 meter at mean sea level. So first, the total BOD load. So BOD per capita per day is equal to 160 into 300 bracket complete to 10 days to minus 6. The value is 0.048 kg per day. The total BOD load is calculated 8,000 into 0.048 is equal to 384 kg per day. Then second, permissible area of BOD loading. The aerial BOD loading at 24 degree latitude, the value is given by the previous slide by table is 2 to 5 kg per hectare per day. Then correction factor for elevation is equal to 1 plus 0.03 into 900 divided by 100. The value is given for correction factor is 1.02 7. Then correction factor for sky clearance 100 divided by 100 plus 3 into 15 divided by 10 is equal to 100 divided by 104.5. Then corrected aerial BOD loading is equal to 225 divided by 1.027 into in bracket 100 divided by 104.5 nearly is equal to 210 kg per hectare per day. Then pond area, the pond area is equal to total applied BOD 5 divided by aerial BOD loading. The total applied BOD value is given by previous slide is 384 and aerial BOD loading is 210. So nearly is equal to 1.83 hectare. So convert into meter square. So 1.83 into 10 raised to 4 meter square. Then detention time or detention period. So pond removal constant at 10 degrees Celsius. So P at 10 is equal to 0.1 in bracket 1.047 10 minus 20. So value is given is 0.06317. So detention period is equal to 1 divided by PT log of 10 LA divided by LE, where LE is equal to 30. So T is equal to 1 divided by 0.06317 log of the 10, 300 divided by 30. The value is equal to detention time is 15.85. So nearly is equal to 16 days. Then pond volume and depth. Total inflow is equal to 160 into 8,000. So value is given 1280 into 16. So the pond volume is equal to 20480 meter cube. So depth is equal to pond volume divided by 1.83 into 10 raised to 4. So nearly is equal to 1.12 meter. So provide depth of 1.2 meter with 3 bore is equal to 0.6 meter. Then pond system provides 6 unit, 4 unit primary and 2 unit is a secondary. So this is the actual 4 unit is a primary and the 2 unit